This is a land of inspiring natural beauty. A land forces the size of the continental United States. Alaska is home to only 600,000 people. On its remote west coast, where the Yukon River meets the Bering Sea, lies Nunam-Ikwa. Previously called Sheldon Point, this Yupik village of 180 people has few modern amenities. Homes have no running water, and there are no roads. Access is only by air or boat. Like most Alaskan villages, the school is the largest building and the center of the community. In the spring of 2000, the village's middle school students attended a unique program that could have a profound effect on their lives.
The Science and Math Enrichment Program is designed to bring Alaska Native students from rural areas, from small villages, to the Geophysical Institute and the University of Alaska Fairbanks. The villages that we selected are the villages in which students are doing among the worst in science and math in the state. Their CAT scores, their national scores are very low. And so we're trying to, first of all, increase their interest and enthusiasm and skills in pursuing science and math in high school.
They're in a formative stage, and this is a wonderful time for them to get this experience.
We bring the whole junior high, we bring their teachers, we bring as chaperones their community members, their parents, their in-laws. We bring them all here. The children are in a very safe environment, and that is a very strong Alaska Native cultural value. We are trying to show them not only skills that will increase their science and math abilities, but also we want to introduce them to professional scientists so that the students will have knowledge of careers that they can pursue in the future.
Middle school students from Nunam-Ikwa and other villages spend their first day of instruction at the university's Geophysical Institute. The institute has earned an international reputation for its studies of the Earth and physical environment at high latitudes.
Well, today the students are going to be learning about the crust of the Earth, in particular the crust of the Earth around Alaska.
Researchers from the Alaska Synthetic Aperture Radar Facility explain how the 11-meter antenna receives data from polar orbiting satellites.
This facility is a means of looking at the Earth's crust through cloud and through darkness and seeing it just as well as when it's fully illuminated.
Using walkie-talkies and grids, these youngsters exchange information to see for themselves how satellite-transmitted data is processed by computers. Then, by reading actual satellite images and geologic maps, they discover how technicians interpret this data.
So this is important with earthquakes, which move the surface of the Earth, and also with volcanoes, which expand and contract as they are ready to erupt and as they subside after an eruption.
1, 2, 3.
With the aid of their own erupting volcano, students use math and graphing skills to predict the path of a volcanic ash plume.
There are about 100 volcanoes between here and Japan, and they are a constant danger to aviation.
This is the arrival of the P wave. This is the arrival of the S wave.
In the Institute's seismology lab, scientists demonstrate how they locate the epicenter of an earthquake and record its intensity. The students discover firsthand how seismic waves travel through the Earth's crust. By observing the buildup and release of pressure with an earthquake machine, the students understand how difficult it is to predict when a quake might actually occur.
When we're trying to pick up the signal, we're going to turn the antenna in a circle, and when the signal gets strong, that means that this yellow ball is pointing towards the animal's collar.
Some scientists rely on satellite observations and radio telemetry in their work. During this exercise, students experience how field biologists track wildlife by using a transmitter to locate the radio collars various animals wear.
I think the benefit's going to come from windows that are opened. I think they're going to go home knowing, wow, this is something that a wildlife biologist does. I want to learn more about that and build their knowledge about it and hopefully go on to pursue that as a future someday.
On the second day of the Institute's Enrichment program, students journey over 60 miles into the heavens to explore one of nature's truly outstanding displays, the Aurora Borealis.
We want the kids to learn about the Aurora because they've seen it before, and we want to take what they already know and expand on it because that's like an educational hook.
The aurora appears when particles from the sun collide with particles in the Earth's atmosphere. Our planet behaves like a giant magnet, attracting these solar molecules to its north and south poles. To better understand how the aurora is created, students perform experiments with electrical currents, magnets, and magnetic fields.
But what happens when I move the magnet is the little meter moves back and forth. To teach, you should always remember to go from the known to the unknown. And all of the students have a sense of the aurora, and we're using that as the attraction tool. And of course, we're helping these students understand that and making it playful by having them build rockets and also measure how high those rockets go, because our intention not only is to talk a little bit about science, but to increase their math skills. These are the coolest kits I've ever built. They have 12 rocket fins. We started the morning by building model rockets and carefully weighing them and making some devices to measure how high they go in the sky. This afternoon they're going to launch those rockets at the only university-owned and operated rocket range in the world, Poker Flat.
During their afternoon here, the students learn how Poker Flat operates before and during the actual launch of a rocket sent up to probe the Aurora.
Welcome to the launch operations room.
Inside the protective concrete blockhouse, they go behind the scenes to see what it takes to send off a real rocket.
Now we're ready when the clock goes to 0 to press the button.
Students also observe how weather, particularly wind, can affect a rocket's flight.
5, 4, 3, 2, 1.
Then it's their turn to become rocket scientists.
I love working with these kids. They are immensely curious. They're very talented. They're scientists. They don't even know it because they're natural curiosity. It's always fun to help them realize that there isn't just one way to solve a problem, that actually any way that you get to the other side is a success.
Using instruments they've constructed, groups of students record each other's launches. Later, they apply mathematics to the data they've collected, determining each rocket's altitude, velocity, and acceleration.
What we're really hoping is they'll get really curious about the world they live in and become more active in the world. And then hopefully later they will pursue this or any other science through their own natural curiosity.
What the students are learning today is how weather is measured on a daily basis and how that translates into weather forecasts on an ongoing basis and long-range forecasts for the Earth's climate.
So today what we're going to do is create our own miniature water cycle.
The students are starting with building some simple weather instruments to learn about relative humidity, about temperature. They also investigated and had hands-on experience learning how to build instruments to measure the wind. One is to build an anemometer that measures the wind speeds. The other is to build windsocks to determine what direction the wind is blowing. The hands-on process that we do today really helps, I think, cement in the concepts that we want to try to communicate.
Art and science come together when students draw various kinds of clouds. They learn how these different cloud types help forecasters predict the weather.
And the difference in electric charge between the top and the bottom can result in lightning. It's basically a fun opportunity to explain some basic weather observing phenomena to the students.
A tour of the National Science Foundation Research Greenhouse on campus helps students understand how clouds play a key role in the greenhouse effect and global warming. To observe a weather balloon being released by the National Weather Service, the youngsters take a trip to the airport. There, technicians explain how such balloons measure temperature, humidity, and pressure in the upper atmosphere.
They are learning that science is fun, and that is the thing that is exciting to me.
At the ice age, long time ago, we had surface permafrost.
Effie Cochrane, an Alaska Native elder, shares a different perspective on observing the weather.
When you live in a camp, fish camp or trap line, you have to go outdoors and go to the outhouse. So you look at the weather. Every time you go out, you just look at the weather. All we know is how to study the wind clouds and the rain clouds and the sun clouds and the ring around the moon at night. Just stuff like that, that's everyday thing when you're living it.
Now, we also want them to have a well-rounded experience here. So generally they stay in university dorms or in university housing. We have them go to the gym where they can play basketball or volleyball. We also take them to Fairbanks events such as the ice sculptures. They loved it.
It gives them a feeling that that the world isn't quite as dangerous and is a little more stimulating than they might have supposed.
What's amazing about bringing the students here is that the Geophysical Institute is the international leader in research. So the students are actually interacting with the foremost researchers in the world.
There's so many professional people that have devoted so much time into creating this, and we're going through each day with 20 people. It's fantastic.
What's been astounding about the program is that we have statistically documented how much the children are learning. We do a series of pre- and post-tests of all different kinds, and in these pre- and post-tests we have documented an average of a 90% improvement in all areas. About a month after the enrichment program, we have a community presentation, and at the community presentation, the students are to display the science knowledge that they learned here to the rest of their community. And it's at the end of the school year when kids are very enthusiastic about leaving school. Despite that, we have had 100% participation. The community presentations prove that not only are they retaining information on the short term, but also in the long term, and retaining it well enough to actually explain in their own words what they learned here, and make their own display boards and instruments.
This is just a first-rate, wonderful opportunity for them to get to experience these things. And the instruction they're getting is just outstanding.
This program's giving them things that we can't do in the classroom. They don't fit on sheets of paper and in books. There's a lot of hands-on. It's wonderful.
All these brilliant scientists, they're willing to share their knowledge with you. It's just amazing for them. It's I don't know, something they're not going to forget for the rest of their lives, I bet.
My favorite thing was making the rockets and launching them.
Doing that fish and wildlife thing, looking for the callers.
I really like science, and this trip has made me want to learn more about science.
I also like the learning about the earthquakes.
You learn a lot of new math and science that you never knew even existed.
And I met new friends from different places. I got to learn a whole new set of things.
It's fun. This program is really, really cool.
If you can make individuals believe in their own abilities, give them a vision of their own possibilities, it's the most important thing. that an institution of higher education could possibly do.
I've really come to understand how limited the educational possibilities are for students in these remote villages, so that when they come here, the impact on them is absolutely phenomenal. It will affect them for the rest of their lives, I'm sure.
But it's good for them, yeah. We never had that opportunity when I was a child.
5, 4, 3, 2, 1. Well, hold it, just hang on.